Hi guys, welcome to the third installment of our Relay Computer video series. In the previous episode, I took you through some simple digital circuits for computing basic logic functions. Uh, in this episode, I'll be taking that idea one step further and I'll try and show you how you could construct an adding machine using the same digital circuits. Now, before we get into how computers add numbers, let's first revise how we add numbers in our decimal number system. So take for example these two numbers being added together. So you start from the units place, you add them together, you get a double digit result. The lower digit is saved as the sum and the upper digit is sent to the next column as the carry. In the next column, instead of adding two digits together, you add the carry as well. So you add three digits and generate a two-digit result. Lower digit is the sum, upper digit is the carry and is sent to the next column. And this whole process repeats again and again till you realize you are just adding zeros together. Now, in the binary number system, we follow this exact same process. So say I had to add these two numbers, 0101, which is 5 in binary, and 0111, that is 7 in binary. Now, if you were to add these two numbers, you start from the units place, add the two digits together. So 1 plus 1 is 2, but 2 in binary is written as 10. So that's a double digit result. Lower digit 0 is saved as the sum. Upper digit carry is sent to the next column. In the next column, again, you add three digits together, you generate a double digit result. Again, you add three digits together, generate a double digit result, and this process again repeats. Now, what's great about this process is that regardless of how large a number you're trying to add, there is this one step that will be recurring again and again, which is adding three single digit numbers and generating a double digit result. And that is actually our final goal. We need a circuit that can add three single digit numbers and generate a double digit result. And using this one circuit, we can replicate it a number of times and add as large a number as we want. So how do you do that? Well, first let's look at a circuit called a half adder, which adds two single digit numbers and generates a sum and a carry. So since you've got two inputs, there are four possibilities, four possible combinations: 0, 0, 0, 1, 1, 0 and 1, 1. Now if you add 0 and 0 together, the sum is going to be 0 and the carry is going to be 0. If you add 0 and 1 together, then the sum is going to be 1 and carry is going to be 0. And if you add 1 and 1 together, the answer is going to be 2, and 2 in binary is 1, 0. So that's a double digit result. So 1 for carry, 0 for sum. Now, how do you implement this using logic gates? Well, we look at one output at a time. Now, if you look at just the sum output, you will realize it resembles the output of an XOR operation between A and B. And that's what our sum output is. It is the XOR between A and B. Similarly, if you look at the carry output, you will realize that carry out is going to be 1 only if A and B are 1. So that's an AND operation. So that's your full adder, an XOR gate and an AND gate connected to the inputs A and B, generating their own respective outputs, sum and carry out. Now, how do you implement this using relays? Well, in the previous episode, I had discussed how relay-based logic gates are constructed. So using the same idea, the top two relays form an XOR gate, the bottom relay forms the AND gate. Now, for quite a while, I was wondering if there was a simpler way of constructing a half adder, maybe with a lesser number of relays. And while I couldn't figure something out, geniuses over the internet posted this. So you've got just two relays computing the same result, an XOR operation and an AND operation, giving us the half adder. Now, let's look at a full adder. Now, this is the circuit we actually want. We need a three-digit adding machine that generates sum and carry out. Now, there are two ways of constructing a full adder. One way is we follow the half adder route. That is, we make a table with three inputs and two outputs and try to solve that table and come up with logic gates that would compute that result. Or we could take two half adders and chain them one after the other, something like this. So in this circuit in front of you, the first half adder on the left hand side adds A and B and generates a result. That result is sent to the next half adder, which adds a carry in as well and generates our final result, sum. And the carry out of the two half adders can be ORed together to get the final carry out of this complete full adder. And if you were to implement it using relays, this is what the circuit would look like. So the top two relays form the first half adder, bottom two relays form second half adder, and the diodes form the OR gate. So for a 4-digit adding machine, you take 4 full adders. The carry out of the first full adder goes into the carry in of the next one, and so on and so forth till you reach the 4th full adder. Since initially when we first start adding numbers, we aren't really carrying anything, so carry in 0 can be set to 0. And that is how you construct an adding machine. If you've got any doubts, put it in the comment section. I'll try my best to answer them, and see you in the next video.